Hello and welcome to an episode of the Clojure Pills screencast. This is a special episode. I'm not talking about a function today, but I'm illustrating the life and death of an S expression. A quick plug about the book I'm writing related to Clojure, the Clojure Standard Library, an annotated guide by Manning. There is a 42% discount at checkout if you use the code that is displayed on the slide. The book is available at the website displayed below in the slide, and @reborg is my Twitter handle if you have any questions or if you want to get in touch. So the idea for this screencast comes from a chat I was having on the Clojurians Slack Clojure UK channel, where somebody was asking about where can I find information regarding the internals of Clojure, how the reader works, how the compiler works, and so on. So as far as I know, there is no such a central place. This information is scattered around the web, but I suggested that a nice experience to have is to just use a debugger and step-by-step follow what happens in the Clojure source code when you try to parse an S expression, for example. And since there is no such screencast or video already, I decided to create one, and I accepted the challenge. And a challenge is indeed because there are so many things that are going on. So what you need in order to do the same is, for example, an IDE like IntelliJ that understands Java and debugging. The community edition is free, you can just download it, as well as installing the basic Clojure plugin, which is also free and gives you basic syntax highlighting, which is all I need for today anyway. You check out master branch from Clojure. Is usually pretty safe, is definitely compiling, even if it's like sometimes in very alpha condition, it shouldn't be a problem. I made a minimal change that I'm going to show you in a second, where I can dump the bytecode that is produced on disk so we can decompile it and have a look inside. And I created also running configuration that is connected to Clojure.main class that is running the Java main that is then invoking into the Clojure REPL directly if you don't pass any other arguments, and a bunch of breakpoints. So what happens when you type +11, for example, something that looks very simple on the screen at the REPL, and you hit return? So the REPL loop is going to read from the standard input, is going to pass the token by token reading to the Lisp reader that is responsible for like character by character going through the input, the standard input, and decide what to do with it. If there are reader literals and other rules. And then when it's created a nice list with all the characters and symbols that were found on the standard input, it invokes the eval, normal eval in Clojure Core to eval this list. Eval is then going into asking analyze to give semantic meaning to the list that was just read. And the semantic meaning is essentially creating a bunch of specialized classes that knows how to translate an expression or a form or a let binding or a native Java interop call into bytecode essentially. So it's going to create the output of the analyze phase is a bunch of hierarchical classes like fn expression, fn method, a body expression inside the fn method. And in this specific case, the plus is a host expression that gets translated into a static method expression. So the only thing that doesn't happen when you type is the parsing of the host expression, because that plus that you see on screen is interned as a symbol and is found by the Clojure compiler as a symbol already, and it is of course loaded and interpreted when the entire Clojure runtime is starting up, when the entire Clojure library, essentially the standard library, is interpreted and ready for work and put into a ready state for later work. So that plus is the only thing that is not happening when you type, but is happening before. Once we have a fn expression instance and all the inner classes that are related to that specific form, the analyze called the compilation phase, and the compile method is going to call essentially an emit on all of the classes, all of the expressions, and each emit has to say something about the part of the bytecode that will be created. So the output of the compilation phase is, in this case, is a compiled class, a bytecode class, and each of the expressions can tweak the class by adding instance variables, static methods, and so on and so forth, depending on the form that Clojure is interpreting. Finally, the bytecode, the class will be literally invoked via reflection. An instance will be created and invoked. And that creates the final result, which is 2, that is then printed by the REPL, and the loop continues back again. So let's see if we can now understand or see those parts which we just saw on the slide in the debugger, where we are going around in the source, in the Clojure sources. So I started the debugging configuration on top of the Clojure master branch, and we got back a nice REPL here waiting for input. So I'm turning on the breakpoints that I had to turn off, because if not, during the compilation of the standard library, we would have seen the breakpoint stopping at the breakpoints. So turning them on, and now if I type 1.1 and I hit return, we're going to jump into the first breakpoint that is in the Lisp reader. So the Lisp reader is invoked by the Clojure side, which is implemented in the REPL side that is implemented in Clojure. And specifically, we are inside this invocation here that is returning the string that is appearing on the console as a list. And this is invoking the Lisp reader. And the Lisp reader is what is responsible in this while true loop to check for each and every single character on the command line. So if we start, we see that the first read is the open parenth, and that means that if we go inside getting the macros, we can see that the macro that is going to be returned to read an open parenth is, you can see it here, is a Lisp is a list reader with a T, not with a P, and this list reader is responsible for reading a list, something that starts with an open parenth and stops with another open parenth. So let's move on, and this is invoked, and this is starting another reading cycle essentially, but just from inside the list reader instead. So the first thing we have is the plus sign, which is not a digit, it's not a macro, but is a special case down here with plus or minus, and that is going to read what is coming after, if it's a number or not. It's not a number, is a space. So what we read is essentially a token, and if we check what kind of token is that, is it a byte space? No, it's not. Read it. So what is that? Let's interpret it. And it's that a false, a true? No, it's not. Is by any mean matching a symbol that we know about, and indeed there is a symbol, the plus sign, that was returned during Clojure compilation, so that during Clojure startup, and so that is going to match, and this is what we are going to return after reading the plus sign, so a symbol. And this symbol is fetched and is added to this list, which is like the partial results so far. We continue our loop, And the next thing is a white space, so we skip it, we read the next one. And do we have an end of line or an end of file? No, we don't. Is that a digit? Perhaps, yes, it is the number 1. And read number is, this is the read number method is where each and every number gets transformed into a specific class. So in this specific case, it's down here. The last case is a normal number, and this is where is translated into a long value. So number 1 is translated into a long right here. And we got that number. We just need to add it to the list of partial results. Let's go for that. And we add it. What do we have next? We have another space. We have another number. So I'll just go quickly through that. We read another number, the number 1, and we add it to the list of partial results. And finally, we reach the terminator, the closing parenth, which is the signal right here that is time to return the reading phase. And here we go. We exit the loop in a second after adding the last bit. And so here we read what is an array list, Java array list, and at this line we are transforming the array list into a persistence list. So it's just a simple transformation from the Java domain of lists into the Clojure domain of lists. From this point on, this is what the analysis phase is expecting. Is expecting a list, which is essentially everything that comes from the REPL. So we are done with the reading phase, and we found the invocation, and this is the last piece. We are about to go outside the Lisp reader, and we are not going back into the Lisp reader because everything from the open parenth to the closing parenth was assembled into a persistent list and is ready for the compiler analysis phase. When I click on the step over button, what happens is that we're not going to see that, but essentially we are coming back into the REPL loop here. We got an input, which is a persistent list, and we are passing that input to eval. Eval is only going to invoke compiler eval, so it's going back straight into Java code. So we can see that if I click on here, I have put a breakpoint in the compiler where this thing is happening. So if we check here, we are entering eval with our form object, and the form object is ready to be analyzed. And the compiler is doing a few things. The eval method is doing a few things. Is preparing the context, is checking the row and column numbers for the metadata and other things. But then is the most important part is certainly going into analyzing the form that just came through. And this is where the analysis phase starts. So what we are expecting is to gradually moving down into the other classes that I mentioned on the slides. FN expression is going to create as many as FN method instances for each potential arity of the expression. Another important bit is that the expression that just came in, if it's not coming as a lambda, it is decorated as such by the analysis phase before proceeding. So we are going to wrap the +11 into an FN of no argument that contains the body +11, and that is what is going to be evaluated. So even if you don't explicitly put that, the compiler is going to do that for you. So don't be surprised if we go inside, for example, this expression here, where is the form that was just created. Sorry, it's not created yet. I need to do another step. And this is jumping on the FN method, but the form, if you look inside the form that was just created now, contains an fn star followed by +1 as the body, and this is the creation of a wrapping lambda before moving on. So that's the reason why after doing this, the next step is when the analyzer is going to, fn expression is going to specialize the fn, the function for each of the arity, through the creation of an fn method instance. And this is the first and the only fn method creation that we are going to see, because there's only one arity, which is the singularity. But this fn method is going to do other stuff inside. So if we follow for a second, actually I have the next breakpoint that I can just jump into, is going to be for the body expression, because that fn method, the responsibility of the fn methods, after checking for important things like type hintings, for the arguments, the return type, see if there is a vararg. So it's doing a lot of stuff, but at the end of that introduction, or that header of things that needs to happen, is going to say, well, there's going to be an expression, let's check, there's going to be a body, let's delegate the body creation to the body expression that knows how to do that. So now we are essentially in the parsing part of the body expression that is going to check what is inside the body of this invocation, of this expression. And I think the important part here is, we can look around for a second or two, but the important part is that is going to verify that there is a plus sign, and we can see what the form is at this point, and that is a symbol, and when that comes, is going to deref the symbol, and the symbol is pointing at what the startup compilation created when the plus function was parsed, and that is it's a host expression, because the plus function in the standard library is inlined, and it contains only a Java invocation for Clojure lang numbers add of 2 numbers in this case, and that is transformed at compilation time, at an analysis time, is transformed into a host expression, which is what it is. So I put a breakpoint in the host expression that we are going to see in a second. Here it is. And the body expression is deriving the symbol. The symbol is saying, I am a host expression. And the body expression then says, okay, parse the host expression. And the host expression parsing is resulting in a static method expression, which is the final output. And the static method expression is what knows, is responsible for the bit in the bytecode that is going to invoke the numbers class add method with 1 + 1. So we can check around a little bit here as well to see if there is anything that I need to mention. A lot of things are happening. You might want to come back and read a little bit more carefully what is going on here. But essentially, after checking for a few things, arguments, we are arriving at the end where it's deciding if it's this host expression, which means Java interop call, is a static method or is an instance method call. And in this case, it's a static method expression, and a new static method expression object is created with all the relevant information. So if we step out again, we are jumping back into the fn expression, and I think from here we can again jump out, because we are we arrived at the bottom of the hierarchy of class that the analysis phase is creating, and we are gradually coming back up. So we are going to see the fn expression again, potentially the fn method, and we are at the compilation phase. So when all the analysis has finished and we have this hierarchy of classes, it's time to call compile on the top of this hierarchy of classes, which is an FN expression instance. By invoking compile, I'm starting all the operations, all the recurring invocation of the eval method on all the expression classes with the, I think it's called the bytecode adapter. We'll see the name in just a second, which is an ASM class, which is the library that Clojure is using to produce the bytecode. So each of these expressions in the hierarchy will have a way to say, oh, and by the way, in this part of the class generation, you should put this line or this declaration or something else. So the compilation is starting that phase. If if we step into, or in this case I have another breakpoint, we can see what happens there. So I'm creating a class writer, and I think the adapter I was talking about is just below here somewhere. Essentially, I need to think about the name that this class will have and which package and stuff like that. And once that name is decided, we can go and check for all the methods that are inside the FN expression and all potentially other things that can be inside the FN expression. And constructor generation, generating the constructor for the class. And so this compile method is quite long, is doing a lot of things, and I don't understand most of them. Sometimes I understand a little part and then I come back and I forget about it. It's quite complicated and is part of the beauty of the Clojure compiler and the Clojure sources in general. There's definitely a lot of complexity going on. Don't let the complexity scare you. If you try hard enough, if you go inside each and every invocation, you might be able to understand exactly how things are working. It might be worth for this to download the ASM library and do the tutorial, because what is happening here with the generator adapter and the visitors class that you see around, all the visits that happens, is part of the protocol, is part of the API of the ASM library. So it might be worth. Emit, I think emit is, we are, for example, now is another breakpoint I put, is the emit method of the static method expression, which is where this invocation to the number class is translated into bytecode, essentially. So you can see, if you check the variables that are around, you can see the Clojure lang number class here. You can see that the method, the related method was looked up by reflection and is ready for execution. So we just need to pass this information to the ASM library and emit that bytecode. We can move on, I believe. So this is the FN method emission of bytecode, and so on and so forth. When we gave each expression class a way to tell what kind of bytecode should be generated, we arrive at the end of the bytecode generation, the visit, its ending, which is this breakpoint that I have here. And the class can be finally loaded, interpreted, and invoked. As I said, I did a little change here. I commented out this if condition, so the write class file is always happening, and inside the write class file, I'm also using a tmp clgen folder that is on my laptop, so we can check what was dumped, what bytecode was created there. So if we go back from here, we've got the bytecode was generated, the class was loaded, and the class loading is happening in this f expression eval. Sorry, the class loading is happening in the analysis phase after the compile method has executed. Eval here is creating an instance of the class that we just created that is called, you can see here, user $eval 6781. And now we're going to invoke it. And the result of that invocation is finally the number 2. So if we jump again from here, I think, yes, essentially I don't have any other breakpoint. What's happening is that the eval invocation for that persistent list is coming back as the number 2, and the value is printed. And the value is printed, you can see it here, we came back at the beginning. We can check what we generated on the class path. What is the class? So let's refresh his view, synchronize, see if there is any. I think it was 6781, if I remember correctly. And here it is. It's a very simple class. So a lot of the compile class was not invoked. It's definitely a simple expression. It doesn't require instance variables or like other vars dereffing, because the plus sign is inlined, so everything is present here. And you can see how the calling invoke on this class is calling invoke static, and invoke static is just calling numbers.add of 1, which is the result of calling eval on the static method expression. So it's just printing here as the invocation of the add method on the numbers class. So I hope this was clear enough. I tried my best. There are definitely things I'm not able to understand myself, and for a long time I won't be able to. So I hope anyway that this was a nice introduction if you want to repeat the experiment yourself and see, for example, what other kind of bytecode is generated when you interpret different expressions, which is not +1. And I think that's all. So thank you for listening, and we'll come back next episode, probably back with a function of the standard library. Thanks again. Goodbye.